Today's lesson is going to be a bit more fuzzy. In the sense that I don't have PowerPoint slides for it. I wanted to make something, but other things to do at the same time, and I'm a bit improvising today. But I hope that I will answer some of your questions that have arisen throughout this course in this lesson. So I will try to target different ones while building something today. Now, what we build today is going to be an application that detects if you are hitting something with your mouse. We have talked about it. I remember Henry at some point was mentioning that, hey, when I click on these lines to remove them, I'm actually making a trick, and the closest line to my mouse is being removed. Or somebody had the bomb fireworks. I don't remember who had this bomb fireworks, but somebody had the bomb fireworks example. And he did the same trick there. So this one, more or less, I can grab it. If I click at this location, it just takes the most nearby object. And the question is, could I make a better system that detects better when I am hovering on top of one object? And that's what we will experiment with today.
May I have a question?
Yes.
Before I forget, one interesting thing would be, because I don't know anything about like JavaScript and graphics so much, is it possible to touch with a mouse some kind of a sprite so that you could actually have the pixel accuracy somehow different than just covering the object with approximating polygons? So are there any good available things with like straight from Canvas or so on, because I haven't done so much graphics?
Not really, but there are some libraries that are doing more or less what we are going to do today.
Okay.
But we will try to implement some things without drawing polygons on top of objects to approximate it. So let's see what the options are. Okay, I'm going to start off with this. Keyboard is a bit funny. With this lesson from, I think it was the second lecture, and I will start to modify this source code, and I will just use the draw polygon function more or less from there, but I will keep any other necessary things here. So the title is going to be hit. Okay, something very strange with my keyboard. Just a second, I need to. For some reason, it turns into some touchscreen mode, and then it acts all the time as if Control key is pressed. I don't know how to explain, but then everything becomes a shortcut. All letters I type. If somebody knows about this problem, it has started to happen recently with some recent Windows updates. Let me know. Maybe I'm pressing something strange by mistake. So hit test, the new title of the layout today. And let's start with just one canvas for the moment. What we are going to use from this older application, well, I'm not going to draw houses yet. I'm not going to draw anything. Maybe we keep this mouse down listener because we are going to interact with the mouse somehow, but this location, I'm going to log it to the console for now. Okay, maybe this is too small. I'm not going to do anything with it yet. Canvas C, we don't need at the moment. I'm not going to use particles or animate them or... Okay, all the vector stuff I'm going to keep just in case I need anything with vectors. Get cursor position, I need it, but maybe this log is unnecessary. And, okay, polygon, animations, no need. Clear canvas, useful function, probably we will clear it some point today. Initialize canvas is useful, all the houses stuff, generate house parameters, not needed. Get random color, maybe we use it. Draw house, no need, I don't work with houses today. Another function to draw house, no need. And draw regular polygon. So I always do this recap just so that you somehow remember about the functions that I'm going to use. Like a bit of a recap. Okay, so I saved the file, refresh the page, perfect, white canvas, nothing wrong yet. So, time for things to go wrong. Okay, so what I want to do on this canvas is draw polygons. I will just draw some polygons on this canvas. And let's make a function that does that. And I'm going to use this draw regular polygon function from here to make several of them. So let's say I start this for loop at 1 because I'm going to say less than equal to a given number, and let's call it number of polygons. And for each of these polygons we will draw them at a location, which is going to be a random location. I'm going to use vectors here. And I will multiply this by the... We don't have this, do we? Variable. And as long as we are defining these, let's say we are drawing 10 polygons, not more today. And yeah, so here we multiply this by the canvas size so that we get them spread around on the canvas, and the Y component also randomly on the canvas somewhere. So that's going to be our location. On the canvas, let's say the radius is 20 and sides is 20. Rotation doesn't need to be specified. So more or less 20, we are drawing 10 circles randomly somewhere on the canvas. Let's see if it works. Okay, so some circles there. And let's say that I want to click on them, and when I click on them, we just make them disappear. So no fancy interactions today. We are just trying to detect if we are clicking on something and making it disappear. I remind that now I'm printing here the coordinates where I click using the mouse. This is the only thing we do here. So, to make it disappear, there is a problem because now our polygons exist more or less as pixels. I don't store the polygon properties anywhere. I just immediately draw them with this draw regular polygon function, which actually is a bad function here because it does two things at the same time. It's not properly defined. Draw regular polygon actually creates a polygon with some properties and puts it on a canvas. So I was probably too fast when developing these, but the proper way would be to make two functions here, create polygon, and this one has a location, a radius, sides, and returns a polygon, and then another function, draw polygon on a canvas, a given polygon. So let's try to make these quickly from whatever mess is in this function. It's not a complicated function, but we can make simpler and more intuitive code in this way, so let's just do it. So I'm gonna copy probably this for loop from here when I'm creating a polygon, and there was a trick here that we didn't start off at 0 because our 0 was this move to beforehand. So now I do want to start at 0 because I'm going to create the first point. Sides needs to be divided by 2. I don't explain all the details now, but if you don't remember, check out the last video. And I'm not going to bother with this rotation anymore. We just draw them as they are. So instead of putting them on the canvas, I'm going to say here points, an array, and in this array I'm going to push all the time a new vector with x and y components. So I just create the points of the polygon with these properties, the radius, the sides. Yeah. But when I return this polygon, I want to return more than just the points. I want to keep track of, well, the points. So this will be part of the things the polygon object contains. I could create a polygon class, but let's just go with this because JavaScript is allowing me to do something like that. And I'm also going to put here center, and this is going to be the location coming just as a parameter, but I just prefer to package it with the polygon. And let's keep also the radius for quick access there.
Excuse me.
Yes.
Why don't you make a class?
Because I am lazy. And JavaScript considers this as an object. So if I'm going to work with polygons later, I need to remember that polygon object contains these 3 properties. If I would have a class written somewhere, I could clearly see the properties. So this way of programming is not the best. But now I gain a little bit of time. So if you want better code, a little better code, then you can make a class for the polygon. But JavaScript allows both of them, so we can experiment and see what are the differences and benefits. I also remind that the class was added recently in JavaScript, so some people may not be totally familiar with that.
Excuse me, what was the code like points, semicolon, points? What's that?
Oh, so this variable, this array that I define here, it could be PTS, for example, the name of this variable. It's going to be an array of points, an array of vectors. So this one goes in the points attribute. In the points attribute. So JavaScript is also nice and confusing enough to allow me to have these duplicate names there. It knows that it's going to create an attribute called radius, and it's going to populate it with the radius of the polygon. So don't be confused about some of these things. I could make it clearer like this. Maybe. I don't know if it's clearer, but I prefer to keep it the full name, sorry. Okay, so creating the polygon, and now when I'm drawing the polygon, well, I'm going to take these canvas tricks from here, begin the path, move to the first point of the polygon's points, and it's 0 component, so x more or less, and same for y, so this is where I'm moving. And now I'm just copying here a for loop, but it's going to look quite different. Okay, I don't need to start at 0 because I'm already moved at 0. So these are going to be line 2. Are going to be line 2 at the points from I, 0 component and 1 component. And if I were to use something that I have learned from you guys in the last exercises, is that if I put this sign here, it unwraps this array into two components. So this should actually work. A line 2 there. And finally, a move to at the beginning, another line 2 for the first point, so that I connect the last point of the polygon with the first point, and it closes the loop. Okay, and then instead of stroke, I want to fill it, because in this situation I want to click on the circle. Here it looks like it's empty, so let's not stroke but fill it. Fill it, and let's make it black for now, but we will experiment a bit more with this later. Okay, so let's delete now the draw regular polygon function. We don't need it anymore. And up here in the draw polygons, which is again maybe not a very good way of calling it, because it also creates the polygons. Let's say polygons create polygons, and this one is going to go to the number of polygons at a random location, create polygon at the location with the given radius and number of sides, and push them into an array. So we just create this array, push them here, and return this array. Definitely stop me anytime something is confusing. So, and
okay, I have a question.
Yes.
About this push.
Yes.
If you have a lot of points,
yes,
and you want to push them to the array, which one is faster in JavaScript? If you know the number of points beforehand, push or ready-made array?
I believe they are the same.
Okay.
I believe they are the same. There could be some, again, strange implementation issues. For example, Juhani was mentioning before that different browsers may have different time complexities for these operations.
Really?
Yeah, it's very strange. More or less each browser, as I understand it, has its own implementation of the JavaScript interpreter, but I don't know for sure.
Yeah,
So
it's a lot of testing.
don't quote me on that, but sometimes, yeah, sometimes, like when you install a browser, why do you choose a browser? If you look at the specs, they may say, oh, JavaScript runs 10 times faster on it, or whatever, but the true reason is that some things will run faster, but some things maybe run slower. So some strange behaviors are happening there. Okay, so I create polygons, and then I want to draw the polygons on the canvas. So now the code is, I think, much more understandable. So draw the polygons. I don't need to go here to the number of polygons anymore because I already have the array coming from this other function, so they are already there. And here, so create polygon is there, but draw polygon on the canvas at the location. So no, sorry, draw polygon function now has the polygon as the parameter, right? So draw polygon already knows all the things there. It just needs to put the ith polygon. So what we did here is nothing. The code will still do the same things, but the code structure, we worked on improving that. Can it be improved more? Yes, I think with Jarmo's observation about the class. So a little bit more, but let's save this and see what happens. Nothing. So what is happening? We have to debug a little bit. I'm going to open here the main function, and let's put a breakpoint in it. Refresh the page. It initializes the canvas, and now I'm using this step over function call to go to the next step. So creating polygons. After creating polygons, I have here an array of 10 elements. They have a center. Okay. They have some points, they look to be proper, and the radius. So this is what we generated there. Now let's see why it's not drawing them. So this draw polygons function should put them on the canvas, but it's not for some reason. I'm going to use this step into next function call to inspect what is happening with this draw polygons function. So it goes through all the polygons, and it should draw each polygon on the canvas. But it doesn't. So now one polygon should be there. Let's inspect also this draw polygon function next. So what happens here? We are getting the context, beginning a path, moving to the first point of the polygons, and making lines to every I polygon. Yes, the problem is here. So this polygon.length doesn't exist. It should be polygon points.length. Okay, so mistake. Draw polygons calls draw polygon, and here this is a problem with JavaScript. So if you would write something like this in Java or C++, it would not even compile. It would tell you, hey, what is this length you are trying to access here? It does not exist. But JavaScript is more permissive, sometimes also harder to figure out why is there a problem, because there is no error in the code here at all. It's just not doing what you expect it to do. Okay, now they are there. Fantastic. And if I refresh the page, why does it take so long to refresh the page? Well, if I refresh the page and the page loads, they should have different positions. And In this kind of time, oh, okay. Well, sometimes browser has strange, strange behavior. So every time I'm getting new circles there, right? Okay, great. Now, let's have this mouse down do something, and let's do it, do that thing that some of you already experimented with, to get the nearest item, not necessarily click on the object. So, let's say get nearest polygon to location, and I'm going to say here location and polygons. So notice now I also don't have any global variables like these polygons, particles. We used to have global variables, but now I'm just passing everything there. So in this kind of way, with these new functions, I also avoid some of those variables, which is a good thing. You don't want to overwhelm with global variables. Okay, so we are going to get the nearest polygon to a location. Or let's make it a shortcut, delete nearest polygon to location. And I think we don't need to do anything anymore here. Yeah, so how would this function look like? Location and the list of polygons. Well, it's finding the minimum distance, more or less, between these two polygons. So we start off with a minimum distance of infinity, and let's say also a variable for index, which one is the polygon that is the nearest. We set it to -1 as a default. Now I'm going to go through all polygons and calculate the distance from our location. We don't have the distance function on this example, but we can implement it. From the distance from the location to the polygon to its center. Remember that I defined the polygon to have a center, a radius, and a location, and the points that it's made from. Okay, I have to implement also that. The distance between two vectors, right? Who is surprised by this? Lift your hands, who is surprised by that? So this is the same as the Euclidean distance function, but written using the vector operations that I have down there. They are equivalent functions. You should be familiar with this by now. Okay, so now we have the distance function. If the distance is less than the minimum distance that we have so far, the minimum distance gets updated. We found a closer polygon that we had before, and that polygon is at the index I. So this one is the one that I'm going to have to remove from our polygons list. Splice function does that. At the specific index, remove one element. Okay, now I think that this should be passed by reference, so I actually may not need to return anything here. I think the polygons are going to miss one item after I call this function. So what I'm going to do now is say clear canvas. Well, canvas is in e.target, one place where the canvas is, but I think C is also accessible in this scope. Let's try with C. I have some plan for this soon. So let's leave it C for now. And redraw the polygons. So I'm going to redraw the same polygons, but now one of them should be missing because I called this delete nearest polygon to location. So drawing them on C again. Hopefully it works. Refresh the page. Okay, no errors. So this works well. I mean, for me, I use this approach for many things. And the reason is I know that even if I click here, this circle is going to disappear. Okay, so I know that if I click here, this circle disappears. If I know that, and if any user knows that, then this interface is perfect. But if you make this kind of implementation for somebody else, and that person doesn't understand this concept, they will maybe, oh, let's right-click here and take a snapshot. Something happened, I can't save the image anymore, it changed. So right-click also behaved as a left-click. Or they just click by mistake in the middle of the screen, and what happened? I didn't click anything, it's a bad usability. So if you know that this is the effect that you're looking for, I would claim it's even better than detecting the absolute shape. Because if your interface is this kind of smartboard, it's not very accurate. And when you try to click on something that is very small, you may miss, not because of your ability, but because of the calibration on this device. So very, very often I use this trick and I find it nice enough, but I know what I'm working with, okay? So in many times this is superior, and you shouldn't really just dismiss it because it's too simple. It has good applications. So yeah, I can remove all the polygons here and empty canvas again, great. Okay, so this is method 1, where we just delete the nearest polygon to location.
Can I ask?
Yes.
I asked about the implementation so far. So if anything is, now everything is static, and the drawing function is implemented inside the listener, so it listens to the mouse action. So if anything is, if you want to make anything moves on the canvas, you have to make the animation loop and put all the drawing functions there, basically. Is this a, I'm not sure about this. Is this a good style to put drawing functions inside the listener, or am I reading the code somehow?
No. So your whatever animation you're going to do, it goes into the set timeout or set interval or request animation frame or whatever. That is going to move your things around. Okay. The listener just is concerned with what is the current state of the polygons or the particles or whatever.
And the canvas.
And the canvas.
Okay, okay.
Yes. So it's a separate thread, if you will.
Yeah.
Even though I don't think we have, I don't know how threads work in JavaScript, but more or less event listeners listen somewhere and the animations should be kept separate. Otherwise you end up with this many indents in your code and some very hard to follow structure. Okay, but another canvas, and now we are going to try to hit the circles. So canvas B. So canvas B, let's just copy everything. Not a good thing. I'm going to have to deal with this soon, but for now just follow me. Okay, canvas B, initializing it. I create polygons again. I draw polygons on the new canvas, and again mouse down listener. Everything should work, but now I have two things. So let's see what happens. Ah! So I'm clicking on the left, but things are getting removed from the right. right. This is now a little bit of a problem here. What is actually happening, I think, is this C variable changes. So this is the reason why you should actually put this event target here. Let's see if now it works, and I will explain why. Okay, something very strange happens here. I click first time, and then all the polygons that were later generated start to appear on the first canvas. So these kind of tricks and these kind of strange behaviors, what I'm encountering here, are all happening because now my polygons variable becomes overwritten by other polygons. Okay, so this is one problem. And this one actually worked. So this was the problem that C became another canvas immediately after, and then the mouse down listeners were working, even this one was working with the new canvas. So these kind of problems are going to happen to you a lot if you are new to this kind of understanding of things. And that's why I'm purposely having them today. Or maybe it's just my excuse that I haven't prepared the lesson well. Who knows? Nobody knows. I will explain soon how to get rid of this duplicate code, but just to see if we are getting things to work now. Let's say here polygons B. Okay, I save the file, refresh the page. So now I have two sets of polygons every time I refresh, and they are different, the ones here from the ones here. I'm clicking on the polygons on the left screen, and now I'm clicking on the polygons on the right screen, and now it seems to work just fine. So see how these overwritten variables, this is something that Jarmo pointed out at some point. Like, when can you reuse the same variables, variable names? And this is not one of those moments. So here you are getting these problems because the listeners will act later on. Okay, so even though I define it here, it will listen throughout the program. So my C variable was changing to the new one, and then this one was actually lost forever. It would only affect on the second canvas. Okay. Now look at this mess. Like, if I'm going to continue with this example, okay, let's continue with this example. Delete pressed circle, a new function. So now I'm actually going to detect when you are pressing the circle. I'm going to copy this delete nearest polygon function from here. Delete pressed circle, I still have the location, I still have the polygons, but what I'm going to do here is update this minimum distance only if the distance is less than the radius of the polygon. So a circle has a radius. If you click near a polygon, and the nearest polygon, you are closer to its center than the radius, it just means that you are clicking on the circle itself, on the black region there. This is quite easy thing. You shouldn't be very surprised. But I need to update something more because this index can still be -1 here if I'm not clicking anything. So if index is equal to -1, console log you clicked nothing. Okay, so in the other example, index always changes to something. Something is always close to you. But in this one, it can be that you are not clicking on anything. This could be very familiar to you already because in the planets experiment, you may have detected if the planets collide using this radius property. But let's see, so now I'm clicking on the left and not exactly on the circles, but sometimes on the circles. And now I'm clicking on the right. So nothing happens here, but if I open the console, it says I clicked nothing 5 times. If I move over the circle, it actually disappears. So even if I go very close to the circle here, I'm not getting any deleted objects, but once I hover the circles, it works. Okay, to identify these things, I'm going to draw some text on the canvas. I'm going to say here nearest, and I'm going to say here circle, and then we're going to have a break. So just bear with me a couple of minutes. I don't know how to draw text on the canvas. Well, good enough. I will move the function somewhere down close to these other draw functions. Now, this is one of those moments when you should definitely use more files, separate the functions that are drawing in other files, maybe have a file just for drawing. If you're an object-oriented fan, have a class for drawing. Yeah, so anyway, so I'm going to get the draw text on the canvas. And what is the text? It's going to be a parameter. I'm going to put it here in this field text function, and let's put it at 0, 0, top left corner, right? And let's make it blue so that it somehow doesn't, it looks different than the circle. I can read it if it's above black circles, right? Okay, and this one I put in the beginning here. I say draw text on the canvas, nearest, and draw text on the canvas, circle. So just to know how the hit test is being performed, like a header there. Refresh the page. It doesn't work. No errors. I suspect that the text is actually here somewhere on top. So I'm going to Google next text alignment vertical canvas. Okay, I think I've clicked on this before. Okay, this is a nice example. So I want this top variant here. So this seems to be good. I go back to the draw text function. I say here text baseline is equal to top. And I also want the horizontal alignment to be left, so I don't want it to be somehow cut in half if it is maybe center.
You also have 2 context lines in your code. I think it's making a problem because you have var.
Okay,
2 times.
I will look at it just now. So, it's not a problem.
Okay.
It's not a problem, it would just be overwritten by the other one. Okay, something is appearing there, but of course it's inefficient. Why would I have 2 of them? So they are doing the same thing. So thank you for pointing that out. And here this is actually CB. Okay, so my second context. I will teach you how to clean up this mess of a code that is happening here soon, but after the break. Now, yeah. this is fine, but the title is disappearing when I click the objects because the clear canvas is happening. Right, so this is a little bit of a disappointment. I could make a trick again because JavaScript is extremely nice. I could say that, hey, canvas, your title is nearest. Okay, I give it a title attribute, and then I can give the CB attribute, your title is circle, and now I can remove this, well, I can keep this draw text function there just fine, but I can put it also here. After I redraw the polygons, I'm going to say, put again the text on top of each particle. So a lot of extra work, but now I still see the text there being redrawn instantly every time I click. So yeah, okay, let's have a 10-minute break, and 15 past we continue.
Could you show the delete pressed function again?
Delete what?
Delete pressed circle.
Yes. So
Yeah, I just wanted to look at it.
yeah, so it's the same as the other one, but
we can add distance less than equal to also the condition.
I'm sorry.
Let's say if we are clicking on the border of the circle.
Yes. So you can put like that,
It's one
but then again, now I'm not sure about these really pixel interactions, what happens. I also have to say that the way I'm drawing now, the circles do not have a border.
Okay.
I only used fill, I removed the stroke. We can play with this even now, but so our draw polygon, if I would add the stroke, then the circles will actually be slightly bigger. I don't know if you can notice that, but they are slightly bigger than if I don't put the stroke.
From the good UI point of view, you could also register a listener on the mouse move and make the nearest circle blue.
You are here. You are in this room. What do you hear all the time?
What?
What do you hear all the time? Really? I thought I recognized everybody, but apparently I'm looking more at my code. Sorry, you were saying?
That if you would like to do it nice way for the UI, you could, in the nearest canvas, you could register a listener for mouse move, and then you could make the nearest circle blue every time the mouse moves.
Ah, so then the user sees that. Yes, it works.
Yeah, I think I've seen that somewhere, maybe when you do something in some vector editor,
Mhm.
it kind of snaps, like the closest object will snap, and then you can have it.
Yeah, of course. We are on a break now, so as long as I don't destroy anything, let's
I'm
try.
not saying that you have to do it.
No, but I am gonna do it. Because we are on a break and I can do anything I want in the break.
Yeah.
So you want to, for the first one,
I think the first thing would be to add event listener for mouse move or something.
yeah. So mouse move listener for this one.
Yeah,
And then you will get like the closest polygon.
I just write here for a quick thing, highlight those and then redraw polygons. So now I'm gonna look for the delete function and I'm gonna say, hey, you word. Oh my. So to highlight it, I'm just gonna say, instead of removing it here, I'm gonna say
Hey,
over
Yeah.
blue. And now when
And then
I,
that's it?
well, no. because my draw polygon function has a hard-coded color. Yeah, hard-coded is tight.
And couldn't you?
Well, I think it would work even without. I think that if it would be some error in JavaScript like null, it would default to black anyway. But okay, not working yet.
Is it redrawing it?
I'm more interested. Why do I get the text, small text saying circle? Ah, it's because I used the title attribute. Okay, yeah. I don't know. Let's see. So. Okay, so I moved the mouse there and something happened. This polygon doesn't have a color. I think that the problem is the polygon at the index should become blue. So I made a mistake.
It's crazy what JavaScript will let you do without saying anything.
Yeah, I hate it.
Mental.
And I'm teaching it at the same time. So. Wow, okay, now I'm painting everything blue. So I also need to make all the other polygons black.
Yeah.
So easy way to do it is like that. I default them into black in this loop that I'm doing anyway. And then the blue one is the one at the chosen index. So it doesn't work. I'm getting errors because I should be here. Sorry. So each polygon change color.
Yeah.
Okay. So
Wow.
from interface point of view, yeah, I think this is a good idea. Only problem is on touch devices this won't work.
And it also probably makes it spin a lot in the browser because it's doing this stuff on every mouse move.
Yeah, but then again, every mouse move is not all the time. Like now, when the mouse is stationary, it's not recalculating anything.
Is there something like top in the debug console in the Chrome? Like, is there something that would show how much is each tab spinning the browser?
You mean like performance?
Like on Linux, you have top. When you run top, it shows you which process is using how much CPU. I was wondering if there's something like this in Chrome.
No, I don't know about the performance thing. So Juhani may know some of the things.
I mean, I've only seen the interface like total an hour now, well, minutes, so it's a bit hard to read, but I think it's there.
I've never used this, by the way.
So it starts profiling now, and it's just then you press stop, and then it tells you what you did there.
Oh. Wow, this is great.
CPU. There's a peak on in the beginning for some reason. Not
In
after.
the beginning. This could be garbage collector or whatever strange reasons. But
Looks good.
yeah. Also,
Not
I
so
have
bad.
very few objects here. So, I mean, 10 objects. Well, let's put more objects.
Let's see if we will have to restart this machine.
Well, I don't know. Well,
Yeah. And now,
what did you expect?
and now move the mouse from the news.
I'm moving the mouse. Now, there is a small problem with me moving the mouse now. Because, okay, first my computer is working very much, but the reason why we don't see this may be that there are many other circles on top of it. Yeah.
For sure. But I mean,
Okay, let's.
Excuse me, one
Yes.
question.
Yes.
You put the text that way that they are redraw when we open the content. When even right?
I'm sorry.
Then here is a circle. You just redraw these when the event comes. When the
I redraw. Yeah, I redraw every time. Every time.
Yeah, I just wonder with the task tree that I put the palettes to the canvas and they what's that they stay there always. But is it a good way to, because we take account the move event from the mouse. Should I always draw these with this in this field?
Well, in animation, for a very long time, there is this concept of layering. So the problem is the canvas by default doesn't have it. But if you remember our canvas experiments here, so I go back to this just because it's here. If I add to the canvas this absolute positioning, and then I remove the white background from the canvas. So now all of those things are on top of each other, but I don't redraw the houses all the time. So the houses have been drawn, but another canvas is on top of another canvas, and this can give you the effect of layering. So in your case, I would just keep a canvas on top and draw those corner things only once there. And then on the bottom is the actual drawing or whatever is happening. But you need to register the event movements on the top canvas always, because here, see, oh, okay. Yeah, this one happens to be on the top and I can still interact with it on click. But if this would be somewhere less on the top, now I can't click anymore. So the event listeners come always from the canvas on the top. So layering is an option by drawing canvases on top of each other. But always register event listeners on the canvas that is on the top.
Okay, thank you very much.
Sure. Now let's get back to this, and wow, something has happened while you were away. I'm gonna undo some of these. You know what? I'm gonna keep it here, all the changes. If you were on a break, you can watch the video in the middle part of the break, because there are not many changes really.
Can I ask something else?
Yes.
About the delete pressed. Do we really need the first condition in the if? When we compare it with the min dist that's infinite? Because if you're going to be inside a polygon...
Are you talking about this one?
Or I'm just...
Well, if you are not gonna do this,
Yeah.
check here. You may have a situation where two circles overlap each other.
Oh, yeah.
And then you have two conditions that will trigger the one on the right, but maybe it's more intuitive to remove the nearest circle still.
Yeah.
So I would keep this.
I didn't take into consideration.
It's okay. I forgive you. Yeah. Okay. So we did some crazy things here while we were on the break, but I'm not going to use these in the later part of this lecture. So what happens now is in this one on the left, it highlights the polygon when I move the mouse. Only when I move the mouse, it makes it blue, whichever is the nearest one to the mouse. So it's a nice nice thing to show the user, hey, this one is going to be removed when you click. Now it immediately even jumped to the other. So it's a neat trick, and if you were outside of the class, then you can check this in the video, but it's not very important. So now let's move on to something more. First, I'm going to teach how to clean up this code. So you can see already redundant patterns. Okay, before that, one more redundant pattern just to get an idea of why this is a bad thing to do. So canvas C, a new canvas, polygons C, okay, problems occurring here. I'm gonna say square. So let's click on squares this time. Canvas C, oh, I have to C all the time, make sure that I'm modifying all these variables. And then, oh, this is polygons B, it needs to be polygon C. So all this problem, if I now decide to do one change in some other place, everything is a mess. So this will need to be fixed at some point. So delete pressed square. So what I want to do here is not create the same type of polygons as before, but give it 4 sides. So it's going to be square-shaped polygons. I'm going to go to the create polygons function. I'm going to add here a sides attribute, and I'm going to default it to 20 so that it's going to work all the time, even if I don't specify it. So my previous code is still going to work. So now I'm going to create polygons. It's going to be 20 all the time, except for the final canvas that we added now, and those are going to be squares. So canvas C is here, refresh the page, and they are squares. And if you remember, they are these rotated squares. Okay. Now, okay, errors here. Errors will constantly appear when you have, okay, now the problem is my delete pressed square function does not exist. If you just use the same function as before, so delete pressed circle, it's not going to be as you expect. It is going to work. Okay, sorry. Again, copy paste mistake, so copy paste. Bad idea, don't copy paste. Can't stress it enough. Okay, so it does work quite nicely, but it works even when I click here. Okay, because it's within the radius. So I'm going to try to click, and it disappeared. So I want to be able to click it there and not disappear because it's not on the object itself. So of course I could make a delete pressed square function here, and I'm gonna do it quite quickly. You don't need to think about this too much now, because I'm gonna show you a really cool thing very soon, how to make any shape work. So wait for, be patient. So delete pressed square, the thing is, okay, square and it's rotated, you have to think a little bit about geometry here, but I'm just going to do it quicker. So what I'm going to do is take the x component of the location and the polygon center, and I'm going to take its absolute value. And in this kind of rhombus square shape, it's enough to take these delta values, and if your distance if delta x plus, delta x plus delta y need to be equal to the radius all the time. So this is what happens on this border. So here delta x is the radius in this location. Okay, maybe I So in this location, delta x is equal to radius. Here, delta y is equal to radius, but the other one is always 0. And no matter where you are here, delta x and delta y are both half the radius. So if their addition is less than the radius, then the same things happen. I don't need to calculate the Euclidean distance there anymore. So this function should work for the square. Clicking, 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 clicking. Error. The distance is not defined. So what did I do here? I'm sorry, I don't need even, well, okay. I still should calculate the distance to this object and then my minimum distance. I could go without it, like what Georgia said before, but I still wanted to work if squares are overlapping each other to get the nearest one. Okay, so nothing, 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 something. Okay, so it works when I click on the tips. It doesn't work when I'm around. I don't want to do this horrible thing every time I'm gonna add new shapes into my shooter or whatever application you want to do where you click on shapes.
Just the absolute values of delta x and delta y will do.
Absolute values.
Like from auto size, because you make the sum. Now,
Yes.
it is okay.
It is
I
there.
didn't see.
It's okay. Okay, now cleaning up the code and then the trick to solve all the possible things. So we have a polygons value here. I would like to handle click listeners for this canvas, for these polygons, and I want, when you are clicking, how to detect if the clicking is happening. I'm actually gonna pass to this function that we don't have yet, so I will write this function. I'm going to pass here a function, sorry. I'm going to pass delete nearest polygon to location. So what is happening now is that I'm going to write a function that takes the canvas and the polygons and what to do when you have the mouse down. So this is going to be a parameter. Because if you notice, it's the only thing that changes here. Otherwise, the code is more or less identical. So handle click listeners is going to be my new function that I want to generate somewhere. It's going to have this common canvas, polygons, and what to do. Let's call it like that. So this what to do is going to be a function, okay? This is something we haven't seen yet. So draw polygons, it's going to put them on the canvas, the polygons from there. It's going to give it also this title. No, this should go. I complicate it too much if I make it as a parameter. So let's keep the titling before. Already. So drawing the text. On the canvas, but I don't know what I did there. So the title is now part of the canvas object, so it's there. And I'm going to give it the mouse down listener. And here, instead of delete nearest polygon, what to do function. So this is now my parameter there. It takes the location and the polygons, clears the canvas, draws text. So this again should be canvas title or e.target.title. Here I think we may it may work also with that, but yeah, okay. So let's see if this code still works. So I only applied it for the first canvas. It still seems to work just fine. So now what I'm going to do, okay, and this was done during the break. Watch video if interested. So this first one has different behavior than the other one, but all the other ones are going to be quite similar. So now I'm going to handle click listeners on this CB, polygons B, and I want it to delete the pressed circle instead. I'm still going to give it the title here, and this goes away. And the final one for the square, I create now square polygons here and delete pressed square. I remove the text, and now it's much neater, much easier to read and much harder to make mistakes, assuming it still works. Yeah, so the circles are avoided quite nicely, and the squares. Good. Now, how to do more complicated shapes. So let's have our final canvas here, canvas D. And let's just copy this code from here. Let's call them difficult. Okay. And now delete. Okay, let's leave it with the square for now there. But what am I going to draw? So in this create polygons function, I'm going to add another parameter that says alter radius. This will be equal to false, so by default the radius will not change. It will be constant radius, so you get a circle or you get a square or you get an octagon. But if this alter radius is going to be true, then my create polygon function will also get it as a parameter there. And inside here, my radius is going to change every time I add a new point in the polygon. So new radius is equal to radius multiplied by, let's say, math.random. Okay. If our radius is set to true, then every time I add a new point, this radius changes, and I'm going to use that one here in the function. If this is set to false, then nothing will happen. The original radius will work. So here, when I initialize canvas D, I'm going to say, yes, alter the radius for these polygons. Okay, I added this true parameter there. And I refresh the page. Wow. Okay, I didn't expect that. Well, I expected that, but only here.
You have in your if statement
Yes.
assignment, if it's
Should be equal to or
There is
just
no
the
comparison.
variable name.
Thank you. This would have probably lasted until the remaining of the lesson. Yeah, thanks a lot. Okay, refresh the page. Okay, but I don't want just 4 sides. It looks quite boring. So the other ones looked much better before. So here I'm gonna put 10 sides. So now the shapes here are difficult. Okay, it even says there, difficult. But they are still being listened with the square function. So if I click here, sometimes it works. Sometimes it doesn't. Like now I'm clicking away, like in the empty region. And I want, when I click here, it not to work because it's empty. I want just to click on the object and remove that object like that. So how do you do that? It seems crazy, like so complicated. What kind of function can you write? But the way I'm going to teach you how to do this is very simple. And I'm going to do the following thing. I will add another parameter here, and I'm going to say true for use random color, which defaults to false. Create polygon, use random color when creating the polygon. Use random color equal to false by default, but it's a parameter now. So if this random color is set to false, then the color of this polygon is going to stay black. But if it's true, we have the get random color function from some other day, it's already here. Then this polygon will have a color. Now, the funny thing is I don't have to do anything and it works because I did something during the break. What I did during the break is in the draw polygon function, I am handling the color already. We needed this because I had this example where the circle turns into blue, so I added this color attribute to the polygons already there. And the draw polygon is making it any color if the color is specified. So easy thing, it's, yeah, you will definitely understand this if you were not in the room. But now, how would you detect what I'm clicking on? If they are colored differently.
Oh, it's not white.
Sorry?
If it's not white.
Well, if it's not white, it's something. But before, if it's not white,
can
it's...
detect the pixels of the
Yeah, so we had not white before also, but now we have different colors, which because of randomness, it's very unlikely to have exactly the same color for 2 different polygons. You could have it, and you could make a function that says get random color not used before, but for this example, and in general, you have about 16 million colors that can exist. And to randomly generate the same one is unlikely, but it can happen. So very good point. And yes, so I'm going to take the pixel color of whatever I am clicking on, and then I will check it with the polygon's color. Equality check. If I'm clicking the color of this polygon, it must be this polygon, assuming they are all different. And that's the hack to do this efficiently. And then I'm going to teach you also how to make them all black and still work. So let's see. Okay, but first to get the color. So instead of delete pressed square, delete polygon with color, given color, something there. So yeah, so this delete pressed square is going to, I'm going to copy it and I'm going to rename it to delete polygon with the color. And I'm going to say, okay, I'm going to say here color. So, no, I'm gonna, yeah. Delete polygon with color at location. So a little long function name there, but anyway, I need to wrap this up somehow. So I have the location there, but I'm going to need get color is equal to get color at location. And once I have the color, I don't need the minimum distance anymore. I just go through the polygons and I say here, if the polygon's color is equal to my color where I clicked, then that's the index. I may still have clicked on nothing, but yeah, so this should work. I just need now a function that gets me the color at the location where I click. So this we already had at some point. When in the Doctor Strange thing, if you use some other color thing, you click on it and you get the color. I'm not gonna look for the code, I'm just gonna do it again, I forgot. I'm gonna Google for it, so. Okay, vaguely I remember how it works. And that part of the code is something that will help me. So I'm getting the context from the canvas. Wow, I need a canvas here. Yes, so to my function here I need to pass also the canvas. Otherwise I can't get the color in this function there. So canvas also comes here now. And get color at location, which canvas. So that one has to come there as the parameter. And yeah, so the canvas I'm getting from the context the image data, but I'm only getting one pixel. So from the XY coordinates, which are location of 0 and location of 1, I'm going to get one pixel value. And this is image data, it says that. And I'm going to wrap it as an RGB string. So return RGB concatenate with image data of 0 plus comma plus 1, 2. And the reason why I do this is because our getRandomColor function does the same. It uses the same way of specifying colors. So now I can use equality checks between one color and another, even though it's this three-dimensional variable there. So, get color at location. If it's equal to the polygon's color, remove it. This may actually work. Refresh the page. Error. Yay. Okay. Canvas get context is not a okay. Location canvas. Canvas location. So I prefer to keep the canvas always the first element, so I'm going to swap the variables here. So, again, amazing what JavaScript lets me run and execute. Okay. Nothing happens. No errors in the console. I have clicked nothing. It's a very smart system. I clicked nothing, I clicked nothing. These still work. Good. So, what is happening? I don't know. I'm going to
I think I know. When we created that function, the new radius, then in that object you didn't update it. Not here. Where we are creating the JavaScript object, like in which you are keeping the polygon. Create polygon.
create polygon. This one?
Yeah. That radius is not the new one. That's
What?
the same that we are getting in the parameter.
This radius?
Yeah, but we are
Yes.
modifying it to the new.
Yes, but I am not using the radius for this color check at all. It doesn't matter what the object radius is anymore. The only thing that will matter is if I'm clicking the same color of the object. So for this particular case with the strange radii, it won't matter. But just to debug now, I'm going to log the color that we are getting here. See if my function is correct, because I may have pasted something strange. So undefined, undefined, undefined. Okay. So
Image data.
sorry.
Maybe the image data of 0 is not.
Ah, yes. I remember this just vaguely. This doesn't contain the data of the pixel. The data component of this contains the value. I vaguely remember from last time. I think this is the reason. But again, this you need to be some HTML guru to know these things. So now it's 0, 0, 0 here. It's quite interesting because you would expect
You last time mapped the data to specifically to RGB to make it work manually. You wrote 3 lines. You unwrap the data structure to RGB. If you look at the strange code, go to strange.
I think it's in the if condition specified the color while matching the color, you specified the condition as less than or equal to. It should be equal to.
Really?
Yes.
That's why they were disappearing.
Yeah. In the yeah.
Thank you. Okay, I'm not sure what Henry was pointing at, but this is probably the reason. So let's try again. So now I'm clicking here. I click nothing. Nothing is disappearing. I get close to this red one. Ha. Okay. Now, before you blink, I'm gonna put 1,000 objects here. Now I'm going to just click many objects that look like some kind of strange butterflies there. Now, with more objects, it could happen that another object has the same color. Probability increases. So in that case, maybe clicking this would also make something from here disappear. You don't want that. So in that case, you need to keep track of the colors that you are using somehow. Your getRandomColor could even be a simple increment value. It doesn't need to be really random. It just needs to be different. So if you have a global variable that you just increase all the time, color codes are just numbers, by the way. So when you write something like this, this is one number in hex in base 16. So you can convert it to base 10 and it will probably be something like, I don't know exactly how much, but something like that. It's probably going to be this is to see if your teacher really knows his stuff. Okay? Well, this should have been a 4. So close enough, but this is a guess. So more or less, this is the efficient way to do this. And I'm going to tell you that about this, if you plan to implement some kind of shooting game or whatever, think that no matter what you upload here, maybe a sprite, maybe an image of something, you could keep just the content inside. Like if it's a picture of a character and it has a white background, or even better, transparent background, you could set the color, a random color, to all the pixels that are part of the object. Like more or less what we did here in this image recognition thing. So here I could put a random color instead of black to the identified object. Like if you really show it this kind of a picture of a giraffe or of a fish or whatever, then you can identify that, make it as its own color, and then you can use this trick to detect the collision when you click on just that specific color. But the problem is, maybe you upload a sprite of something like Mario or whatever. Okay, that's the Mario, I know. So PNGs or GIFs, even animated GIFs, usually have this kind of transparent background. So when you have transparent background, it's very easy to identify that, because you only have to look at this. So this fourth component controls the transparency. So if it's going to be a totally transparent pixel, then you can just leave it white or not even color it, leave it with no color, but only use color for the pixels that are not transparent, and then you clearly identify the image. So you could make a shooter quite easily where all your characters are just painted with one single color. That is quite boring. You maybe want to retain the colors, all the colors from here, but say that, hey, all of those colors actually mean this color code, this color ID. So final trick what I'm going to show you is that you can do this effect without having the rainbow, the many color effect. You can actually do it by still keeping the black shapes from the beginning. And to teach you that, I'm going to actually add another canvas. Let's put it E, but let's make now canvas C invisible. So now our canvas E, what our canvas E is going to do is somebody is saying something. So what we do is, okay, in canvas D, I'm going to remove this true.
You'll basically overlay the same shapes with black, but keep the event listener on the canvas behind.
More or less.
Which one is on top?
I'm not going to overlay. I'm going to do something else. That's why I said more or less.
Oh, okay.
Okay.
But one thing what I'm going to do is I'm going to keep the same polygons D everywhere. I don't want to create random new polygons elsewhere, which is a little problematic. Okay, let's see how this looks like now. I'm going to call this canvas E helper canvas. This is going to be called helper, and it's going to display the same polygons as canvas D. And again, it will delete polygons at location. So now what has happened is I have this problem here. It doesn't work anymore at all. So because I removed the colors from this loop, from this function, now they are back. And you can see there is this dependency between the two canvases. So now I'm clicking here, and actually all of these three get removed, but one of them is not getting updated. It's a little confusing what is happening there. Okay, I'm a bit not sure how to implement this now with this structure that we have here. Okay. We are gonna do something strange, but hopefully okay. Don't know what to do. I'm a bit in a checkmate. Okay, I don't like what I'm gonna do, but I'm gonna do it. Clear?
Mm-hmm.
So hard copying of polygons D into polygons E variable, and yeah, this is not gonna be the best thing in the world, but I have a copy of those polygons. They have the same properties, the same order, same indexes, but the color is going to be black in the second case. So maybe not the best way to implement this, and I even have an error. Sorry. Different languages have different functions, and this one converts it into a string, then parses it back into an array. So this eliminates the pass by reference problem. So now when I click on the things there, they won't affect Canvas D anymore. A bit confusing, sorry about it, but yeah. So now I can still click these things here, and in the right it doesn't work because everything is black. I would actually expect something to be removed there, but
So are we reading the color from the left side?
yeah, so we will be reading the color from the left side when clicking on the right side.
Yeah.
Well, actually, it should be vice versa. Oh my god. Because this helper canvas should be the one with the colors on it. Oh boy. Yeah. Well, what happens if I just do this? So very, very confusing. Okay, so now what I try to finish here, even though it's very messy and yeah, sorry about this, I will try to explain at some point. So we need to pass to this one, to this delete polygon with color, also canvas E, because we are going to use this canvas to get the color of the objects that we are pressing. So I hope it becomes somehow not totally confusing, but okay. So when I'm defining canvas D, I actually will define canvas E also, so that they are both available. And this handle click listeners will get another parameter at the end, which is canvas E. So I just do it now so that it works, not that it is very nice code. So helper canvas comes to the handle click listeners, and this what to do function will get the helper canvas as a parameter as well. And now my function is actually this delete polygon with color at location. It's one canvas, but also helper canvas is there. So the get color at location is not gonna use the canvas anymore. It's gonna use the helper canvas to get the color at the location. If this works, I'm really lucky. Oh my god. This actually works. So the numbers here on the right, you see they are showing different colors, even though I'm clicking the black things on this left side. So I am getting the color at the location, and I'm getting now there is a problem with these polygons. Okay, I think we need to wrap it up. We will finish this tomorrow, and I will have a better code structure for this part. But okay, the main idea is that we will not even show this canvas. We will hide it entirely. That canvas exists only in memory. It is just there to have this quick access using the color for the sprites. So it's still going to work no matter what colors, or even if they are all black here, but that other one will be just in memory and just for the helping aspect. I'm going to finish maybe this code now in my office, and tomorrow we will begin the lecture by looking through how it works. So before we begin today's lecture, we look a little bit at the last one from yesterday, because I did a little bit of modification while I was in my office. It's not much. I tried to limit the changes as much as possible and deal with the mistakes that happened in class somehow. So somehow the code structure was not proper for handling this thing here. So just as a reminder, what we had is this clicking, you remove whatever the nearest object is. Here you had, okay, some error there. I will check later. Here you had the clicking on the circles, so clicking outside the circle does nothing, but clicking on the circle, it works. And here we were handling these squares, so you had to be there. Here we had the method on color, so this should have been clear already in class. So whatever you click, if it's no color, then nothing happens. If it's some color, then the object with that specific color will be removed. And here we have exactly the same thing, but instead of using color, we use the color from this other canvas. So we are drawing the objects in their original color, in this case black, but every time I click, I will get the color information from this other canvas that can be even hidden if you don't want to display it. Here we're displaying it for educational purposes. So more or less I'm clicking this black item here, but I'm still going to get the color information of whatever the object had over there. And I'm removing it through this equivalence. So it's a trick that actually many systems that work, for example, with drag and drop on the canvas, or these kind of small games where you have to shoot different elements, they actually have something like this built in the background. The disadvantage of this method is that you're using twice as much resources. You're using two canvases. You can also do this detection if you're inside the polygon other ways, more complicated geometrical ways. But this one is quite nice, and it also handles very well when objects are overlapping each other, like here. So, of course, when I click here, it's going to delete the one on top. Otherwise, if your method is going to be more geometric, you also have to consider what is the so-called z-index. Like, do you want to remove the one on the top, or do you want to remove maybe all of them? If you want to remove all of the things in a region, then this method with the color won't help you. So it all depends on application, but I just wanted to demonstrate a little bit about what can be done. And yeah, one more thing before we proceed. So the way I implemented this here, every time you click, you will loop through all the polygons and find the one with the color, with the key, with the color key, and remove it. But if you are familiar with JavaScript or anything that has a hash map, you can use the color as the key. Here we have different colors. I didn't really check thoroughly to make sure they are different colors, but you can simply have it, if the hash map contains a specific key already, try generate a new color again. So that way you can do it. But using a hash map, you can have constant time removal of the objects here, no matter how many you display in the scene. So this is quite a powerful trick, I think, that can be helpful for whatever purposes.
I have a comment also to that. Hash map gives you the ability to use unique color codes, check them or try again. But how about just generating keeping up a global counter for color so that you would generate colors in order so that you will never encounter the duplicate?
Yes, that is better. So colors are really just numbers.
Yeah.
They are just numbers starting from 0 until 16 million or whatever. You can just keep it a 0 and then a 1 and then whatever. But the problem with that is, no problem, but from educational perspective, if I would have done this implementation here, all of them would look black, almost black.
Well, you can adjust the color a little bit. Yeah, you are right.
I know, but I just mean, in general, I prefer this random because from educational perspective, you understand what I'm doing.
Yes,
But
yes.
from implementation, you should go that way. So to the computer, it won't matter because it will detect the subtle shift in color, even though you don't.
Yeah.
So you want it to be able to do that. One more problem with this implementation that you should be aware of: edges. The edges of a polygon, when you're drawing them on the canvas, are rasterized. That means that if I were to zoom very, very much, whatever is happening here, you will see some effect here where actually different shades of color are appearing. And if you were to click on such a, okay, now I'm going to the canvas where the color detection is going to work. If I click here, it will register a color, so it's not empty, but it says you clicked nothing because nothing has exactly the color on this border. If I move my mouse a little bit to the left, it's gonna remove it. But these are problematic cases. Now also a little bit of a discussion. What are you going to implement? If it's a type of a game, these borderline cases are not good to be so strict. What I would do in this helper canvas, I would actually draw a little border around the object because I want my players to be happy. If they nearly miss the object, maybe they actually will get it if I do that. If I'm too strict, then they will be like, oh come on, I hit it, but nothing happened, it's a bug in the system. So this is again now touching more on usability, on what you want people to feel when they interact with your application. And all of these tricks can be considered. So, of course, the borderline case is an issue, but it's 1 pixel that will cause your app to behave slightly differently. If you increase the border a little bit, then it's going to be nicer to your audience. And in the same way Henry pointed out a long time ago, I was trying long ago to delete links in this application by clicking them. And I used the same strategy that I would just select the segment that is nearest to the mouse. But Henry was speculating that, okay, I would do it the other way and whatever. One way you could do it is draw very thick lines in another canvas and use the color. So every line a different color, but thick color, like a thick line, like 10 pixels or whatever. Then even if you click somewhere near to the line, you actually still click on the line uses more space than what it visually represents. And final thing before we move on, I mentioned that simple thing with just the clicking anywhere nearby. Okay, this doesn't work anymore. Yeah, Flash is disappearing. But more or less, in this application here, we have some clustering algorithm happening, and you have the ability to interact with the algorithm by dragging and dropping centroids. So these blue things are called centroids. And when you drop it, the algorithm starts to do something again and whatever. Here, I don't want to click exactly on the circle. I actually have this nearest idea implemented. And the main reason is if I try to use this board, I won't be able to click exactly on that circle. Board has some tolerance, has some error, and I will have to be very careful when I click, and I have to learn what the offset is, what the problems with the board are. So for this demo, I have no issues presenting it in class, for example, because it works with the simplest way we studied before. Also interesting to say is if you use for the visualization purposes something called the Voronoi diagram. So this Voronoi diagram that you see here, the lines on the right, they have the property that any point inside a Voronoi cell is closest to the centroid in that cell. So if I'm moving now a little bit here, I know that I'm going to start to drag another point from here. So depends on which side of the border you are. It's an indicator for the user that, hey, you're actually going to start to drag this one if you click here. So many tools, many things that you can play with. This is a very nerdy interface. It's for research or whatever purposes, not really for some kind of user-oriented application. But who knows? Maybe you will need to know these things someday. Okay, and about the code. So from the last time, I did add a few comments there. I ended up using the same polygons, but I am handling them on the E canvas and on the F canvas. And the trick what I did so that I have the polygons still drawing with black color on this one, it's a dirty trick. It's not the best thing that you can do. I have this parameter draw original black color. So if this one is set to true, here it will make it black and it will not draw the random color there instead. So a bit of a trick, but it works. You can check it out. And the last thing I want to touch on before moving on, from code quality point of view. So from code quality point of view, we talked also a little bit yesterday. Jarmo was asking, like, why don't you use class? Or why you do something, or why you do something else? And many times the reasons why I code something in class that is not optimal is to show you what suboptimal looks like. Because many people do a specific thing and then they encounter some problems, and if we encounter them together, then you can understand a bit better that, hey, maybe the other way, like how we implemented the particles and the segments using these clear defined classes, is better, or maybe not. If I say something like, I'm lazy, I do it this way, it can also mean that that's what developers tend to do when they want to make a fast application. So my lazy means more or less that I want to fit in the time frame and finish before the lecture ends. But there is a reason why I don't write just the perfect code there. If you look actually here on the right, for this Doctor Strange episode, I have a version with 4 underscores, 3 underscores, 2 underscores, and 1 underscore. They are all practice sessions, because if I don't do them, they won't happen in class. I mean, I'm not gonna hit the, I'm not gonna be able to finish in time, or I'm gonna have some unexpected error that I just have no idea how to deal with. Some lessons had more rehearsals, some had much few. But the idea is, in the last rehearsal, I actually had even more sophisticated application and very good code structure. But if I would just replicate that, then you would not learn what mistakes can happen and what other things can happen. So I choose to just let things happen as they want to in class. So, yeah. Okay. Now, a lot of discussion, but we move to the next topic.